So this is where the bow is born. You know, back in the day when we were machining our risers have always been 100% CNC machined.
Yep.
And we used to start out with a big piece of billet, which is, if the riser profile was, 30 inches long, it was a piece of aluminum block that was
at least that big.
And had to be machined away. Now, with our volume, we've got a forging that's basically near net, right?
Yep.
And what that allows us to do is not have to cut away all of that excess material. So with a reflex riser design, we've got a long, stable riser, parallel limb platform is what the bow's gonna end up being.
Really, we're cutting about 90% of the material out of this, and it makes us one of the biggest aluminum recyclers in the state. But what it does for us structurally too is get the grain structure of the aluminum in a stronger state, because it's already, like Brad said, in a near net, in the shape of what the riser is eventually going to be. So we get better fatigue life out of this, and we get better material properties.
Often we find ourselves, as our product changes, sometimes from one year to the next, there's some very aggressive changes.
Just as fast as we had to develop a product, we're developing tooling to actually make the product, and it's brand new most of the time every year.
We see that all the time. Also, you walk through the building like, oh, what's that machine? And yeah, we built it.
Even though this is an automated process, it's still hands-on craftsmanship that's happening. Here we have a robot, which is an automated process for the repeatability of some of our different drilling components, but it still requires human beings handling and touching every riser, loading it. Once they're coming out of the robot, we're still doing fine detail work, where we're getting all that expertise and that American-made craftsmanship that's in every one of our bows.
As our product has evolved and technology has increased and really the demands for efficiency, the way that we build bows and the standards at which we build bows have changed along that way.
We've implemented a lot of new technology in our limb process as things change. Limbs are something that we get to design our own blend, just a rectangle with our blend of glass fibers to our specification. And then all the finish work is done here, actually. So if you notice, we pan back here, we are grinding these limbs with CNC machines. And this will come in with a big diamond wheel and cut our belly grind into this stick. You can tell how much material we're actually taking off of that limb. But that's not a finished limb. They come over to our robots, and we got 3 going right now, and they really do the finished sanding and get the limb to our spec. Super quality control checked in here, and these robots run constantly and are perfect. These limbs are just super, super important. Manufacturing obviously takes time, and we're pounding as many bows out as possible. Some of the things that slow it down, though, is our quality checks. Like it has to pass very strict standards to get out that door. So we have multiple powder coating booths. Powder coating is something we do on most all of our parts. Matt patented a process to powder coat limbs back in the day, and if you look through here, you can kind of get a glimpse of that. They're dipping it in iodine, letting it dry a little bit, and then iodine's actually charged, and you need an electrical charge to get powder coating to stick. So keep following the assembly line over, and we're going to get to a spot where we actually do the film dipping, put the pattern on the parts. This is the film that we use. It goes on top of a bed of water, and we custom built these racks to hit it at the right angle. But this is a sugar, basically, is what it is, and that's why it dissolves, and what's left is the ink.
When we decided to bring film dipping in-house, we built a building specifically for it. We worked with other companies that had already done it. We were kind of getting feedback at the end that this is really one of the best dipping facilities in the country, which was a great honor. That wasn't like our main goal that we wrote on the board, like let's build the best dipping facility in the country, but as we did it, we do it right.
So Bill's putting on a Mylar graphic with our limb graphics on. It's going to go into a hot stamp roller. He's loading the machine up right now. When that roller comes down, it sticks our graphic to it and gets it ready for top coat, where we seal that graphic. But this is a big part of just every bow gets its own limb graphic to distinguish it and for the name.
We've always built a very high-end product, but when you're pushing the limits across everything that you do, it requires different processes, different forms of measurement, different types of machines to get that accuracy. When your volume increases, you need to be able to build faster. You need to be able to manufacture faster, but yet keep that accuracy, and the quality there. Once we get through the whole component manufacturing, then it comes to final assembly.
So this is where all the parts that we just looked at come together. This is final assembly.
Now it's about being efficient. It's one thing to be like, yeah, we can build these bows, but we need to build a lot of bows, and we need to build a lot of bows every day.
Every single one of the bows that are ordered are made one at a time. And what Jeremy's doing right now is the final quality control. He's looking at every detail. He's got a checklist of things that he hits, that they didn't miss a part, that things look good, that there wasn't finish damage to the part, so that every single one of these bows that go out are up to our standard, which is a very high one.
We can make great parts in a very efficient manner, and we know that the end result is going to be something that is best in class, the best user experience. And when we put that bow into a cardboard box, we did everything in our power to make that bow be the best it could possibly be.